Hello everyone, Don here with the next progress report on my repairs and upgrades to the airplane. As you can see here, my last video I was working on these spinners. This was the first one I did. That band around the base of that was a piece of masking tape. I ended up cutting off basically an inch off the ends of it with the saw, the regular chop saw with just a plain old carbide steel bit blade. Works the best. I took that piece of block and pressed it into the back side of that spinner, and then I tucked it in a little bit, and then when I cut it off, it shaved off, just a little bit off of this, because that was 3/4 inch thick, so it'd make a nice clean cut, and it wouldn't, yank on this and tear the thing out of your hand. So I was able to cut them down, so that's roughly about 6 inches. This is the first one I made. Turned out pretty good, but I put it back in the lathe and did a little more polishing on it, and then I ended up getting a couple little pinholes there from the porosity of the aluminum from the welds. So I might have to try and polish it a little more, sand it down a little harder. And then this was the other one that I showed that I had just welded is all. So now it's all finished, and this one I gotta say came out damn near perfect looking. It's absolutely gorgeous. Again, I cut it down, so this one's done. I'll just try and sand on that a little more, because these are fairly thick. I mean, these things were I can't remember, they were probably over a 1/16 inch thick, and the tubing was about 1/16 inch, so but there's plenty of material there. And then this is the spinner that was on the plane. It ended up hitting the ground and denting it, so I tapped the dent out of the thing, and if you look close enough, you can find it was real tough to get it out and get it clean. Just touching it, you get marks on it already, but it looks like brand new again. So essentially that's how this other one's going to be made, so it fits right in that center hole like that one. So I'll give you an idea of what it looks like with the spinner on when it's all said and done. It's going to be kind of like that, except for there'll be a couple of plates. This 1/2 inch plate will be on there, and it'll cover up these heads of the bolts, and then this will fit into a recess in that 1/2 inch plate. So there'll be two pieces on there, because I got to put a 3/8 inch backer on here before you put the bolts in, and then this 1/2 inch plate I'll make it'd be basically a ring. It'll just be wide enough to come around here. It'll be recessed in the back with some pockets, so when it goes over top of there, it hides these. The 3/8 inch plate that goes on first will be just like this. It'll have a center post coming out of it, and then the second plate goes on. That'll set right inside the second plate, and the bolt will go down through into the center stud, just like this thing does. So, but I'm happy with those. Those turned out exceptionally nice, very nice. And then that, of course, that hole's got to be enlarged out to, I think it's a 5/16 bolt is what that one was. It'll be similar to this, but it'll actually have a hex head on it, because the original aircraft had that was a steel sleeve with a bolt on the top that held that cover over the actual Hamilton hydromatic propeller, whatever they used to call that thing on the real ones. So I polished up on that, finished that one up the other day and then turned my attention to making the plate for the bottom of the engine block. And I did manage to get to the local metal supplier, and we dug through all their scraps and finally found a chunk of 3/4 inch aluminum plate, and it was a drop. It was like 20 inches by 36 inch. I said, well, I only need 12 inches of it, so they were going to cut it off for me. That was Thursday. They said, oh, they'd have it done by Thursday, but I had to work, so I said, I'll come back Friday and pick it up. And he said, well, we got our Christmas party on, at 1 o'clock, so we'll be closed after that. And he says, all right. So I show up there Friday at 12:30, and they were already closed. Everybody was still there, but the gates were all closed. But anyway, I went ahead and, as you can see, I got the plate in there now. Now the bolt holes do match up a lot better. There was a couple here, one or two over on this side, that was just a hair off. But these holes were just drilled out to a 6 millimeter, and that's what that bolt is. But the actual pan itself, I think it's in the house still, they have like a little over 7 millimeter holes. So when I go to make the aluminum piece, these holes will actually be drilled out to at least 1/4 inch, because 6 millimeter is 0.236, and then 1/4 inches, you know, of course, 0.250. So there's about 14 thousandths more. So it either be 1/4 inch or what is after that, 30 seconds larger than a 1/4. So, and then what happened? I redesigned it. I had to get the notches around here so it clears this. This is just the holes that were in the plexiglass. There's a couple other holes in here that were in the plexiglass. These ones I tried to locate. I did locate it fine, but when the machine came and did this little thing to pocket it, it does what they call a smart ramp. The bit comes down and it goes into the center and it ramps in down to your depth of cut, and then it'll do a pocket command. Well, when it went through the first time, it went in there, ran, the stepper motor skipped a beat and it kicked it off center. So this one got drilled off center, but I'm pretty sure the hole's exactly where it needs to be, because this is the hole that's going to have to be just a pocket in the bottom of this plate to put an O-ring around there, and then the hole drill up through there, and that's going to come down to the oil tank for the vent, because that's the vent that goes up to the PCV system. So I'm going to use that to come right through the bottom of this plate I put on here, and it'll 3/4 inch plate, and it'll vent the tank. So the drain hole will probably be back here somewhere. Now this is just a great big plug in there, and because this one cut off, because I drilled all the holes first, and then it pocketed that, and it threw it off, and I knew it was off, but I went ahead and let it, because the holes I was more concerned about these perimeter holes, and then it cut this one, and then when it was cutting that one, it skipped again. It hit and caught because the bit had gotten dull, plus I had a screw right here holding this plate down. Wherever there was a hole, I put a little tiny screw in it to hold it down to the wood. One there, and there was one here. Well, it turned out it was right there on the edge of this, so when a bit came around and hit it the first time, bang, it knocked it off center. So it threw it off a little more that way and a little more this way, but it's okay. I'm pretty sure I got the holes where they need to be. So when I cut them out, they're fine. And again, this is the original pickup hole for the oil pump, which that'll be closed. That's a 18 millimeter hole. I'm going to try and find a little freeze plug, little brass or aluminum steel type freeze plug that you can find on the side of a motor of a block, engine block. They make those oil galley plugs is what that would be. I'm going to try and find one, but it's 18 millimeter. That'll be plugged up, and then this is coming off, and the fitting goes on there because that port is tied right into this, and this is just a plug. So I can take that off, put a fitting on there, and then run a hose right from there to the bottom of the tank, which will be right in here. So as you can see, that took off. So, and then also when it cut this outer perimeter, it shifted it, because I've got more material here, less material there, because it was the y-axis. The x is left and right, y is back and forth, and it knocked it off, so it cut short. But like I said, I was more concerned with getting these holes laid out. So the pattern's great. The problem was, before I mentioned that it cut the other one out a little large, and I mentioned that it might be out of calibration. Well, that's what happened. I forgot to mention that in the video, but that's what happened with the calibration was out. And what I do is I take a tape measure, stretch it across the table, and you want to check the calibration over as long a span as you can. I used to check it with just a 1-inch micrometer to measure it down to the thousandths, which is fine, but I run this over a 24-inch span, and I take a piece of tungsten and I sharpen it like a pencil and put it in the router motor, and then I put it right over top of like 1 on a tape measure, and I tell it to calibrate it to move it 24 inches, and it moved 24 inches and like 200 thousandths. It was over 3/16 inch off in the X. So then I fiddled with that and played with it and got it right down to 24 with just the naked eye, which is going to be just fine for what I need. So then I did the Y, and it was out about the same. So the only thing I can figure is this CNC machine is powered up with a outlet strip, power cord strip, and when I turn everything off, I shut off the power strip, because the power supply for the stepper motors is also plugged in. So I've got the monitor, the computer, and then the stepper motors plug is down here somewhere. This guy. And if I plug that in, you'll hear the motors kick. But I left it on. By turning this off all the time, the computer is powered down and it has a little big, like a 2032 battery in there to help retain memories for being off. And I think the battery went dead, and it also pops up on the screen that it lost memory. So it must have been from turning that off. It must have finally run the battery dead and lost the memory. So I recalibrated it, but now I just unplugged that to keep this in calibration. And before I cut it out today, I did the same thing, put the tape measure out, and I run it 24 inches, and it was still spot on. So that was confident enough to do this. And you can kind of see here where I used little screws to hold it. Well, there was one right here. There's what's left of it. There's just a little nub sticking up right there. But the bit caught that and chewed it up because it was right on the edge of the hole. And it ended up busting the 3 flute tips. But all that was left was cut the perimeter. And it cut it pretty good. This board's not perfectly flat. So when I go to cut the aluminum plate, I'm going to have to do a mill cut on it first to make sure it's true and flat before I cut it out. But I'll start on the bottom because I have to cut the pocket for the pan, the inside depth of the pan first, and then and I can probably peck the holes just to locate them with a countersink. And after that, the inside pocket is all done for this big hole. It's just going to be a recess about depending on how big the O-ring is that I get. I'm just going to put an O-ring, set an O-ring in there, and it'll set up against the block, and this will get squeezed. And it's just an air passage, but it's trying to just keep the oil from, mixing with the air is all it is. It's not crucial, but I got to get an O-ring first and measure the thickness, but it may be like an 1/8 inch O-ring. They'll generally be fatter than 1/8 inch. When you put it in there and then bolt that on there, it'll squish up against the block and be captive inside this little pocket, and then there'll be a center hole going through for the actual drain to go down to the oil tank to work as a vent. And then this, that's the drain, that's the vent. And then this bigger hole back here is because there's a big metal plug in there that hangs down below the block. So that's just going to be a pocket into the bottom of the pan. So when this goes up on there, if that thing was ever to kind of work loose, that is the oil pump return. That's the inlets here and the outlets there. So I think they put that in there to drill the passage through the block, and then they just put a plug in it. And it's an oddball size. It's like a 22 millimeter, and you can't get a 22 by 1.5 or something like that bolt or plug. So I'm just going to leave it and just make a pocket deep enough so that it'll go around that. I can shave the head down about half the thickness, but the pan's going to be thick enough that that should be all right. So, but anyway, this is just some old 3/4 inch plywood that was outside, and it's a little wavy. So it didn't cut all the way through in some spots, and it cut through in the other spots. But the bit is junk now. I can resharpen it. I've got a little gizmo I bought for doing end mill sharpening. It's a wedge. Oh, here it is. It's meant to be used in a milling machine with a vise because it's got all these different angles on there. So it sets it this way, and you do one grind. You sets it this way, it does another grind, and it tilts it differently. I mean, there's 3 positions on it, and then this collet is all numbered on there for however many flutes, and you loosen this up and it spins, and there's a ball bearing in there that locks into detents. But you can do 2 flute, 1 flute, 2 flute, 3 flute, 4, 5, 6 flutes, because all the numbers are on here to do that. But it's a tedious, time-consuming thing. And I do have I bought a cutter, not a cutter, but a grinding wheel. It's usually down here somewhere, but I'm not seeing it offhand. Well, it's probably tucked away somewhere with all this junk. But anyway, I can sharpen them, but it is time consuming. They do work good. And these are carbide, they're cheap. So this is 6 mil. I'm gonna order some. The largest collet I have for this is a 5/16 or 8 mil. So I found some 3 flute aluminum 5/16 I'm gonna buy, because pocketing out all this aluminum is gonna take time. So I want a little bigger. Like I said, this is basically 1/4 inch 6 6 mil to 1/4, and then the 5/16 would be just a little bigger and takes a few less passes on all the porting and pocketing. So I'll pick the material up tomorrow for that. And I still need to get a piece of 3/8 inch thick material as well to make my spacer. And then my friend, he's got a Lycoming 0235 on his. So we were talking the other night, and it turns out he has the exact same SAE1 pattern, same size 3/8 inch bolts. So when I make my plate, I can make his, but his can be made out of 1/4 inch, maybe 3/16 1/4 inch plate for the backer plate, because he doesn't really need the backer plate. But I need that to put the stud in the middle, and then the second plate with his 1/2 inch will be just like mine. It'll be pocketed out to fit over, but his is safety wired. His bolts safety wired. The bolts screw into the flange. My bolts go through the flange and nuts on the back. So I have to make his plate that covers the heads of the bolts kind of like a channel all the way around, so the safety wire can go from pairs. You do two at a time, safety wire them together. So I got to make it so his will clear the safety wire and the bolts, and then the same thing. It'll just slip in the front through there with the center post. So, but that should look pretty sweet on the plane after it's done. All right. One other thing I've been kicking around idea is this is all fuel injection on this engine, and I was thinking maybe converting it over to a carburetor, get rid of the fuel injection. The biggest problem with the fuel injection is the oxygen sensor. I can't run avgas, so if I go somewhere out of range that I'm going to need fuel, it's going to be a problem of getting somebody at the airport, if anybody's at the airport, that can run you uptown with a gas tank, come back with some pump gas. And then I'm using, this is pre-alcohol fuel engine. This is a 1990. This is before they started putting the 10% alcohol in. So they won't run as well with the 10% alcohol. They'll run richer because you need a richer air fuel ratio to compensate. It's about 14.10 instead of 14.7. With non-alcohol gas, it's 14.7 is your stoichiometric, 14.64 if you want to get technical, but 14.7, it's the same as atmospheric pressure. So 14.7, but then when you get 15 or 10% alcohol in there, you got to run it reprogram it for 14.10, and I can't reprogram this computer. So I always have to use alcohol-free, and not every gas station sells alcohol-free. Up here, Country Fair is about the only one that sells that stuff. And it's $1 more per gallon, but it's premium, but it's only 90 octane. So the idea is if I go to fuel injection, get rid of the fuel injection, I can get rid of all this, get rid of these fuel injectors. I'll make a new manifold. I'll cut out some end plates out of some aluminum, like that 1/2 inch plate. I'll buy some more tubing, and then that spinner I made is the perfect size to make this center body. I've got 14 of those caps. I put a ball cap here, weld flames out there, drill holes in the side, weld it on, and put a Rotec TBI slide carburetor on it. It's a non-float bowl. There's no float. There's no fuel reservoir or anything. They call it a throttle body injection, but it's not fuel electronic injection. It's not even a mechanical injection. It's a pressure-operated, a vacuum-operated, manifold pressure-operated diaphragm system, and it's very simple. Just go to Rotec's website, or Rotec, that's R-O-T-E-C. They make those 7-cylinder, 9-cylinder radial engines down in Australia. Well, they're making a version that used to be called an Ellison TBI carburetor. The patents expired years ago, so they started making their own version of it, and they work really great in there. They can be mounted in any orientation, upside down, topside down, this way, that way, any orientation whatsoever. And it's a slide carburetor. Instead of a butterfly, it has a slide like late model, if you ever see any late model 2-cycle engines, snowmobile engines, they use a flat slide carburetor. The slide opens it this way. And there's no accelerator pump. Again, it's just gravity feed fuel can come into it, and then the vacuum on the engine when the throttle body's working, the venturi inside, it sucks in the fuel. It's a real neat system. But they got a bunch of videos on YouTube. It's just called a Rotec TBI fuel system. And they're very simple. they're $1,000 carburetor though. So, and you got to get it from Australia, so you got probably 2 to 3 weeks before you get one. So, but anyway, I can eliminate all this. And then my other problem is the ignition system. This is the coil pack. When this thing fires, it fires 2 plugs at the same time. It fires cylinder 1 and 2, and then next time it fires 3 and 4. 1 and 2, it'll fire 1 on the compression, it'll fire 2 on the exhaust. And then next time it comes around, it'll fire 2, but it fires the plugs on the waste. It's called a wasted spark. So it sparks at top dead center. Every time the piston comes to top dead center, it fires a spark plug. One time's on the compression, next time's the exhaust, and then back to compression again. So there's 2 triggers going in here. You got a power wire and 2 signals, and then it comes back to this little igniter module here. And then this little module has a power from the computer, also a wire, positive power. Has 2 triggers in for each side of the coil, trigger 1, trigger 2. And then it has the 2 wires that go out, and then the 2 triggers from the computer come in. And that's what's depicted in this book here. This is a book. Here's the computer, and it's transistors, as you can see. There's some resistor transistors in there that the computer fires these triggers. And all it does is come in and it fires these. This is a transistor pack. That's all it is. There's just 2 heavy-duty transistors in there. So you just have 2 separate triggers and then a common ground. Yeah, that's all there is. And then it goes out to the coil. So my thing is, okay, what can I do to trigger this? I was wondering, will a magnetic trigger work? So I ended up taking the distributor off my engine here on the car. It's a magnetic trigger for an old Ford Duraspark ignition. So it's just orange wire and a purple. Orange wire is positive, purple wire is ground. So I took and pulled the pin out of here, made a little jumper because I got spare pins, and I plugged it into there, plugged it into the orange wire on the distributor, took the ground wire on the distributor, grounded it to the ground tab here on the motor, put the battery on, had charged it up, put it on there, pulled all the plugs out, and then I took the distributor, and I remember when I was testing the ignition system in the car, the distributor has to touch the body. It's got to ground to the engine. So first I tried it, nothing sparked. So as soon as I grounded it like up here onto the steel part, spun it, bang, 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 every time it fired. And that's an 8-rotor system in there. So every time I spin it like 1 full turn, this thing fires 8 times. So this 1 and 3 fired, so then I switched over and did the other trigger and spun it again, and it fired. And then this is all computer controlled, so it's variable timing. But because when you're flying an airplane, you don't really need much variable timing, I can take and set up a magnetic trigger somewhere in here on the flywheel. It's an aluminum flywheel. I can drill and tap and put a small screw head in there, a round head screw that when it passes the magnetic trigger, it'll trigger that transistor and fire it. It doesn't need any power. The magnetic trigger generates an AC voltage, and that's all it needs to trigger it. But it is a positive negative type polarity. Positive will give you a positive pulse, and a negative will give you a negative pulse off the other side because it's a sine wave. But it's still AC, but it still interprets it like a DC signal, and it's enough to fire it. So all I would do is take on the flywheel, like if this was a flywheel, I'd put a screw here and a screw there, put a sensor here. Actually, I'd put, say, a screw here inside, and then this screw would be here, and I'd put 2 sensors up here because you need 2 separate triggers. One trigger will trigger off of the bolt here, and the other one will trigger off the screw, which will be over here. They got to be 180 apart because it won't fire. They'll be out of sync if you don't. So have one wide one and one narrow one. So 2 sensors be stacked, 1, 2, and then as the trigger comes around for the first one, the other trigger will be over here, and then when it comes around, it'll line up with the inside one, and then it'll fire the cylinders just like it will. And then you have to plan on where to put that to get it to 20 to 30 degrees of timing. This engine would probably be more in the 30-degree timing range. It could be just fixed timing because it'll start just fine with 30, 32, 4 degrees. It's not going to hurt it. So that's the idea. Since I'm going through all this trouble, the exhaust I took off just to clean up. Had to get the roll sander on my die grinder out and polish. It's over back here on the bench. Had to kind of clean up the insides because from welding it they kind of warped a little bit. So I kept working them and sanding them until I finally got them to a decent slip fit to where this will physically move now on the plane a lot easier. But that's pretty much done, ready to go on there. I've got a piece of 5-inch stainless tubing coming. Should be here tomorrow. It didn't show up this weekend either. So I'm probably gonna make kind of like a muffler now, instead of, because this is going to be too short. If I put this like up in here, it's going to be real short. So what I'm going to try is I'm going to mount it like this crossways, so I can put in as wide a piece as I can. And then I'll have the pipe come in right in the center, but it'll come in offset, centered like this. It'll come in this way, so when the exhaust comes in, it'll swirl around. And then with this on here, then I can still run my 2 tubes, one out each side, just like it was before. This time I'd curve them down a little more, make it maybe a little longer. I still would need to put a piece of stainless out here just to help protect out here. But with the muffler failing before, it was blowing exhaust gas right there. I can still see the tin on that from the heat. So, like I said, there is an insulation fire blanket in the back, but it's not much. I mean, it eventually would burn it, but it's going to be essentially that size. That's 5-inch, except for it'll be one piece. So that'll kind of mount right there, and then I can still run the 2 legs straight out. So once that gets here, I'll work on that. I got to pick up that piece of aluminum tomorrow. Maybe I'll look see if they got some 3/8-inch to a 6-inch wide drop. Grab maybe a foot of that, but $120 for that 3/4-inch plate. I'll have an 8 by 12-inch piece of that left over for making other stuff later on if I ever need to. But because that's kind of the idea. Here's the cam sensor. I wouldn't need that. I might even be able to use these sensors. These will probably still trigger it because it's just a 2-wire sensor. There's a cam and a crank, and they're two different ones, but they're identical. But this one works off of, there's 2 single pins, a 2-pinner, and a 3-pin for the cam. And the crank has 6 on it. Has 1, little space 2, big space 1, little space 2. So I can't use these for triggers without grinding off. This I could use. It needs to be 1-to-1. I could use this one and this one, but the 2 sensors, you know, I can't use the same pins with 2 sensors because it'll fire this one here and it'll fire that one there, so it won't work. I need 2 pickups. So, I mean, there's a way around it. It just has to be a metal type because this is the magnetic part. So, but I can eliminate all this, get rid of the throttle body. That carburetor is very, very small and light. Get rid of the idle air control. Everything for the fuel injection. The oxygen sensor be replaced with a thermocouple. So, and it'd be a simple switch. So, it'll all make it lighter. And I mean, this will be most likely more fuel efficient, but those Rotec TBIs, I guess, it has a mixture control, so you can lean it out just like a normal airplane. They don't have a choke. They do have a little primer, but they're slick. You have to check them out. So that's a thought. Right now, I'm thinking about it. Kind of leaning to it now. They know that I can trigger this. It'll work fine. Alright, sorry, the battery went dead, so I swapped out batteries, and this one's got 1 bar on it, so it's probably going to go dead on me too. I didn't bother charging it up. Alright, well, that's going to be it, folks. That's kind of my thought process right now. Get that tube, get the exhaust going, get the metal. I still have to finish doing all the tool paths and such to cut that part out, order up some new bits tonight, get some new bits coming. And then just get back on it again. But the first thing is I can't try and restart it with the new exhaust until after that aluminum's made. The oil tank, I did dig around. I got some 032. It's kind of thin stuff, but the fuel tank is pretty similar to this anyway. I'll see if this will weld up. If not, I'll have to get something a little thicker. But there's enough material there to make an oil tank. So, all right. Well, I'm going to go ahead and end her there before this thing dies for a second time. Otherwise, it was going to take me an hour to charge one of these up and go again. So, all right, as always, friends, feel free to leave any comments, questions, concerns. As it come along, I'll answer them, and appreciate everyone taking the time to watch these videos as always. And feel free to leave them comments, and I will get going on this project a little more. So, right now, the temperature out here is just, it was like 15 this morning when I got up, and it never got hotter than 20 degrees today. So, all right, I'll try and get another one up maybe in a day or two after I get the material and do some more planning, and might be able to cut out a couple of these plates and try to get the spinner going. I still need to finish up the cowling and the wingtip. The lights, turns out the light kit's coming from Australia, so I don't know when that's going to get here. All right, everyone, that's going to do it for now, and I will see you on the next one. So for now, this is Dino Don out.